electrical energy and power. Consider a conductor AB. If VA is more than VB, then electric current will move from A to B. Consider a conductor AB with electric potential VA and VB such that VA is greater than VB. Hence, electric current I is equal to delta Q by delta T moves from A to B, where delta Q, the amount of charge transferred in between AB in delta T second. For amount of charge delta Q at A, the potential energy is equal to VA into delta Q. Similarly, potential energy at B is VB delta Q. The change in potential energy is delta U potential is final potential energy minus initial potential energy, that is VB delta Q minus VA delta Q, that is VB minus VA into delta Q. So this is minus V delta Q. Where V, the potential difference between A and B, if the electrons were to move without collision, without collision, inside the conductor. Then this change in potential energy is the change in kinetic energy for the energy to remain constant. That is delta K is equal to minus delta U potential, that is Vi delta T, by which the velocity of the particles, velocity of the electrons is supposed to increase. But as observed earlier, the electrons move with a steady velocity, move with drip velocity which is steady due to potential difference. An electric field acts. The electrons are accelerated in between two collisions. Accelerated, gain velocity in between successive collision. With the nearby atoms inside the conductor. Hence, energy of the electrons or kinetic energy of electrons are shared within the atoms of the conductor. Thereby, the atoms vibrate more vigorously. Hence, heat the conductor. That is, the change in potential energy, that is, the change in potential energy, or that is the amount of kinetic energy, is dissipated in the form of heat energy, in the form of heat energy. Or delta W is equal to VI delta T, or delta W by delta T is equal to VI, where electrical power P is equal to delta W by delta T, that is VI is equal to I square R is equal to V square by I square R. V by R, or that is V square by R. Since according to Ohm's law, V is equal to IR, IR into I square R, I is equal to V by R square by R. So smaller the resistance or electric power is inversely proportional to resistance. Since in a circuit V is constant, an electrical appliance marked 100 watt to 20 volt means P is equal to VI, or 100 watt is equal to 220 volt into I, or current I is equal to 5 by 11 ampere. That is, this is the maximum current the appliance can operate without breakage or destruction. This is the maximum current the appliance may work without damage. Sometimes if the potential is raised in the circuit by some reason, then it is destroyed. Again, P is V square by R, hence the resistance of the appliance R is equal to V square by P, that is 220 into 220 by 100, that is 484 ohm. That is, more the wattage, smaller the resistance, or you can say that more the wattage, smaller is the, or smaller the resistance, more is the power. More is the power of the appliance, electrical appliance. In transmission of energy, in transmission of energy from place of production to place of consumption, care is taken so that loss in transmission is minimum. Loss of energy in transmission is minimum. It is done by reducing the current and reducing the resistance of the conducting wire. Resistance of the conducting wire.